Welcome to the Ground Control Galileo installation training video. In this program, we will be installing a 1.2 meter satellite system with a non-penetrating roof mount. This is by far the most common type of installation for this product. Prior to any installation, make sure your laptop is loaded with the appropriate installation software. Here the installer has Internet Explorer, a copy of the Galileo training CD-ROM, the CPE installation program for commissioning, and the SatMaster dish aiming utility. The Galileo equipment will ship in several boxes, normally to the dealer that installs the system. These components are the 1.2 meter dish reflector, seen here from the back, 300 feet of high-grade 1694A coax cable, the gateway indoor unit, seen here fully connected, the dish arm assembly, which will hold the radio electronics in place, the mounting bracket, seen here attached to the back of the satellite dish, the dish radio, which consists of a transmitter and receiver, seen here being connected to the waveguide bracket, and a non-penetrating roof mount. The non-penetrating roof mount is named for its ability to be used as a mounting platform without attaching to the flat roof. It stays in place by weight alone. With this mount, make sure to cinch tight all bolts so that there is no slippage at any joint. Weight is added by placing about 10 to 12 cement bricks in the guide channels. Bricks are purchased inexpensively at any home improvement nursery. The first step in assembly is to remove the 1.2 meter dish from the box. When we say 1.2 meter, we mean the dish itself has a surface area of 1.2 square meters. Place the dish on top of the cardboard so it doesn't scratch the surface. Next, open the box with the adjustable mounting bracket. And place it on the back of the satellite dish so the bolt holes are lined up as shown. Check to see that the notch on one end of the dish lines up with the open end of the mounting bracket. Locate the 4 lug bolts that are used to mount the bracket to the back of the dish. Finger place all the bolts into place and ratchet them down. The mounting bracket is now installed on the dish. Loosen the 3 nuts, which opens up the size of the post sleeve. The sleeve opening needs to be large enough to slip over the non-pinned post easily. The dish is now ready to be mounted. Simply slip the mount onto the non-pinned post. Next, you will need to loosen the bolts that lock down elevation on the mounting bracket. It is important to loosen these bolts to adjust the elevation of the dish. Note that there are 4 elevation bolts that need to be loosened. Once the satellite dish has been precisely pointed at the satellite, you will tighten all of these bolts to lock the satellite dish into place. Under the mounting bracket are 3 bolts that lock down the azimuth. You will need to use a ratchet extender to reach and loosen these bolts. To raise dish elevation, use a ratchet wrench on the elevation adjustment bolt. Pulling back on top of the satellite dish helps move it without binding. The next step is the assembly of the dish arm that will hold the radio electronics of the satellite dish. Use the included hardware for this purpose. Attach one of the 2 support arms to the side of the dish and finger tighten the nut. Attach the other support arm as well as the main arm that fits in the slot at the bottom of the dish. Make sure not to tighten any bolts just yet. From the front, simply attach all 3 arms with the long bolt provided. And tighten all bolts and nuts on the arms just installed. The radio mounting bracket is installed on the end of the dish arm. This device will hold the radio unit in place in front of the satellite dish. There are only 2 bolts used to secure this device to the dish arm. The snow cone-shaped feed horn is installed next and placed into the mounting bracket. Note the orientation of the feed horn as it is placed into the mounting bracket. Tightly finger tighten the 2 bracket bolts. If these bolts are too tight, you will not be able to rotate the radio unit in order to skew the dish later on. Locate the transmitter and unpack it from its box. The Galileo transmitter is rated at 2 watts, which is twice as strong as the direct-wave platform. Part of the equipment needed to install the transmitter is a waveguide spacer, which includes an Allen wrench, O-rings, and 4 screws that attach the transmitter to the feed horn. Place one of the O-rings into the circular groove on the waveguide spacer, and then use the grease from one of the red capsules to coat the O-ring. This is dielectric grease, which can be purchased at any auto parts store. Make sure to coat the entire ring, as this helps with waterproofing the equipment. Now assemble the 4 transmitter mounting bolts with the star washer closest to the bolt head. Note the orientation of the spacer as it is gently placed on the feed horn assembly. Use just 2 bolts to hold the spacer in place for now. Now place another O-ring into the circular channel on the transmitter. Use grease from one of the red capsules to coat the O-ring. Make sure that you do not touch the clear plastic film covering the transmitter opening. Grease, even from your finger, will warp a signal, making the transmitter ineffective. Now gently install the transmitter onto the dish assembly. Watch to make sure that you do not slip and coat the plastic film with grease. If you slip, use Windex or other cleaner to clean the plastic film. Now install the other mounting bolts and use an Allen wrench to tighten them down. Now perform a third and final O-ring installation on the LNB receiver. Again, be careful to only grease the O-ring and not the plastic film that covers the LNB. Note the orientation of the LNB as you attach it to the mounting bracket. Be careful not to smear the grease when you position it into place. Use the supplied screw bolts and secure the LNB. The radio unit is now installed and ready to be skewed. The next step is to figure out where to point the satellite dish to locate satellite AMC4. To do this, use your handheld GPS receiver to give you your exact latitude and longitude for your installation location. Here, the GPS receiver shows elevation, latitude, and longitude. Locate your Galileo work order that comes with every installation, and find the section on Dish Pointing Parameters. In this installation, the GPS latitude is 35.26 degrees N. The N stands for Northern Hemisphere because we are north of the equator. GPS longitude is 120.65 degrees W, or west for Western Hemisphere. With this information, you can use a handy program called SatMaster, which calculates your pointing information. To do this, simply double-click on SatMaster from the laptop and then select File, then New, then Look Angles. A screen appears that allows you to enter information that will give you your pointing parameters. Your customer name is the client you are installing for. The satellite name is AMC4. The site latitude in this case is 35.26 degrees N, the N meaning Northern Hemisphere. The site longitude is 120.65 degrees W, the W meaning Western Hemisphere. The last item you will need to fill out is satellite longitude. This asks the orbital location of AMC4, which happens to be 101 west. This number will never change for the satellite because the satellite is fixed in space at this longitude. Pressing OK gives you your pointing parameters. You are only interested in elevation, azimuth compass bearing, and polarization offset. Back in the work order, write down dish azimuth as 134.07 degrees. dish elevation as 44.02 degrees, and dish skew of negative 25.57 degrees. These will be the working angles you will use in pointing your satellite dish. First, raise the elevation of the dish to 44.02 degrees. Pull back on the dish when you turn the azimuth adjustment bolt to keep it from binding. On the side of the mounting bracket is the elevation indicator. When you raise elevation, the indicator will show you the dish elevation in degrees. In this case, the dish has been raised to roughly 44 degrees. Back on the work order, the dish azimuth is 134.07 degrees. Use a compass to find this heading. And then point the satellite dish to that compass heading. Place an inclinometer on your transmitter and rotate the radio unit to the skew angle you wrote down earlier. In this installation, the skew is negative 25.57 degrees. Negative simply means you are using numbers going counterclockwise on the inclinometer. Now connect a 10-foot length of coax cable to the LNB receiver. Connect the other end to the input connector of the front of the BirdDog satellite finder. Turn the BirdDog on by pressing and holding the on button until the unit turns on. Then press the left button to scroll through the available satellites until you come upon AMC4. There are two AMC4 channels to choose from. Choose AMC4KH, K for KU band and H for horizontal polarity. Now slowly sweep the sky by rotating the satellite dish by hand. The BirdDog will indicate when the satellite is found. Note the top meter shows signal strength. Obviously not all satellites are found this quickly, and you may need to raise or lower your elevation slightly in order to find it with your azimuth sweeps. The rule is, take your time and trust your compass reading. Once the satellite is found, tighten the sleeve nuts of the mounting bracket around the mounting post so that you can use the azimuth fine adjustment screw. The satellite signal should not be lost, but if it is, use the fine adjustments to relocate it. The elevation fine adjustment screw is on top of the mounting bracket. You are looking to get the highest signal strength possible on the BirdDog. The azimuth fine adjustment is on the back of the mounting bracket. Prepare to spend at least 10 minutes fine-tuning the satellite dish until you achieve the highest possible signal strength reading. In this case, the highest reading is 82. Using the BirdDog, fine-tune the skew of your dish by slowly rotating the radio unit. Use the bottom meter reading to dial in the highest possible number. Now we are ready to connect the high-grade coax cable to the LNB receiver using the supplied water-resistant connector. The first fitting contains a rubber O-ring used to make a water-resistant seal. Now attach and twist on the cable. Screw it on as far as possible. And use an open-end wrench to tighten the fitting a bit more. Do not over-tighten this connection or you may damage the LNB. Tighten the O-ring connector against the cable connector to complete the seal. Now cut off a short segment of rubber tape and peel off the white plastic backing. Stretch the rubber tape as close to the LNB as possible to cover all exposed metal. And then tightly wind the tape around the connector to create an excellent waterproof seal. Cover the entire connector, including part of the coax. To keep the rubber from breaking down in the direct sun, wind electrical tape over the rubber tape. The connector is now sealed and protected from the weather. The process is again repeated with the transmission coax connector. Try to keep cable runs under 170 feet from the satellite dish to the gateway and door unit. If you need a farther cable run, use the supplied inline amplifier at the midpoint in the receive coax cable. This will give you a total distance of 300 feet. There is no need for an inline amplifier for the transmit coax cable. Make sure to use tie straps liberally with all your installations to keep them looking professional. Consider using plastic split loom to cover your cables from exposure. There are numerous locations to have your cable enter a building, and each installation is different. It is always best to find the alternative to drilling a hole through the roof for your cable run. Finally, attach a grounding cable to your transmitter block, as well as the dish arm and the non-penetrating roof mount. Grounding is necessary to shunt away static electricity buildup. If not performed, the radio electronics will fail intermittently. Connect the grounding wire to a cold water pipe, building steel, or other approved grounding site. A coax grounding block is used to ground the coax shielding, usually at the entry point into a building. The two coax cables will run from the satellite dish to the Galileo IDU shown here next to the installer's laptop. Note the RX and TX connectors on the back. Connect the receive cable to the RX receive jack. The yellow tie strap is a simple indicator to show that the cable is the receive cable. Next, connect the transmitter coax. For commissioning of the gateway, use a crossover network cable to directly connect the IDU gateway to the installer laptop. Now turn the gateway on by pressing the rocker switch. On the front, the power light shows the unit is turned on. You are now ready to begin commissioning of the system. To do this, double-click on the CPE installation wizard. Follow the on-screen instructions and enter all requested information. These steps are covered in greater detail with your online materials. Once you press the last button and commit the installation, you will need to call the Network Operations Center to verify your dish is well aimed. The operator will normally ask you to rotate the radio unit and adjust azimuth so that they can see that you are on target. Keep your work order handy to access information quickly if the operator needs it. When the operator is satisfied with your aim, they will give you the green light to lock down the satellite dish. Be careful not to touch the radio unit as you lock down its mounting bracket. And now lock down the 4 elevation bolts. Finally, lock down the 3 azimuth bolts. Inside, the gateway status light will glow a steady green. This means your system is fully online and ready to be tested. To do this, open up Internet Explorer and type in the gateway IP address from the Galileo work order, making a login window appear. Type in your login name and password provided on the work order. The Ground Control Administrative screen appears. Select Faults to show a wealth of information about the current status of the gateway. To check to see if you were able to reach the world outside, use the ping command and test an IP address such as the primary DNS server address. Or simply start surfing the internet. You can now directly connect the gateway to the customer's network router. Every installation is different and can vary between very big to very small to the unusually unique. If the customer doesn't have a router, consider using a $70 Linksys purchased from any computer store. We certainly hope this program has taken some of the mystery out of satellite system installation. It really isn't as complicated as many would believe. In the worst of situations, always know that ground control is here to support you 24/7.